Hello everyone. In this tutorial, I'll give an overview of the program by showing the interface and features in a general way. So I have the program open here, and my recommendation is to use the interface maximized to the screen size to avoid clipping of some items. Here on the top, you can find a menu bar which contains some basic options for managing files, visualization of the model, and also some options for exporting or viewing the results. Just below, we have a toolbar with some shortcuts for the file options, some camera control options like panning, zooming, rotating, and fitting, and also options for drawing the structural model like inserting nodes, elements, and so on. The created model will be displayed in the canvas, which is this large white area. And on the left hand side of the interface, we have a modeling panel used for creating the structural model and providing analysis options. You can select between one of the 5 model types, 2D truss and frame, grillage, or 3D truss and frame. I'll leave it as a 2D frame. You can only change the model type for blank models when there are no nodes or elements created, otherwise this option will be blocked. The analysis type can be selected between static and dynamic. For dynamic analysis, you have to set some parameters. For example, the solution method, the time step, and you can provide damping and initial conditions as well. And then coming back to the static analysis, you can switch between load cases and combinations. Initially, you have just one case, but you can create cases and combinations in this auxiliary dialog. Then you can start building your model by creating materials, cross-sections, nodes, elements, setting support conditions, nodal loads, element distributed loads, and creating time functions for dynamic analysis. Each of these buttons opens an auxiliary dialog where you can set each of these attributes. For example, in this window, you can create new materials with these given properties, and the created materials will be listed in the table below, where you can change the properties of previously created materials. Each material receives an ID number in the order of creation to identify them. And as you can see, the units of the program are fixed. We tried to adopt metric system units that are common in structural engineering applications, but currently you cannot change it. The same logic of creating materials also applies to the creation of cross-sections, nodes, and elements. As I said, nodes and elements can also be created by inserting them with the mouse using these toolbar options. Here I am creating some nodal points and connecting them with elements. I will also show the ID numbers of the nodes and the elements, which is very useful for modeling. And these elements that I inserted with the mouse are created with the full material and cross-section, and they can be edited in the auxiliary dialog for elements here in the table of created elements. Once you have created the nodes and elements of your model, you can apply some conditions to them. For example, in this window, you can apply forces and moments to the nodes. You can select a specific node or a set of nodes to apply the conditions. Only the components of the selected model type are available. In this case of a 2D frame, you can apply a horizontal or a vertical load, or a moment in the out of plane direction, which is the z direction. And the same logic of setting nodal loads also applies to support conditions and element loads. The creation of time functions is not available for static analysis, only for dynamic analysis. On the bottom, we have an information table that gives some generic information about your model, such as the number of materials, nodes, elements, degrees of freedom, and so on. And if you click on a node or element, it will provide you some basic information about the selected object. For a node, it provides the coordinates, for example, and for elements, the length and the ID numbers of the end nodes. Right below it, we have an addition table where you can change the conditions of the selected node or element. For example, for the selected element, I can change several properties, including the type of connectivity and load components. And for nodes, I can edit the support conditions and the load components as well. Uh, all of these properties can also be changed through the list of created nodes or elements, which are located in the auxiliary modeling dialogues. And this table here is just a shortcut for doing this. Okay, so once your model is created, you can perform the analysis by clicking on this button. If I try to run the analysis of this model, I get an error because this structure is clearly unstable. So for doing this, I will open a model that I have already created. Uh, it is a simple 2D frame. I will leave the analysis type as static. And as you can see, this model has multiple load cases. And I will select the second one. Now I'm running the analysis, and if the structure is stable and the analysis is successfully completed, I'm able to access the results. As you can see, the button to run the analysis is now disabled because the analysis has already been performed. This button will be activated again if you change anything in the model, so you can run the analysis again. The result options for a static analysis are the deformation of the structure and the internal force diagrams. For this case of a 2D frame, the internal forces are the axial force, shear force, and bending moment around the out-of-plane direction. And you can also check the values of the support conditions. For the deformation, you can change the scale factor. And if you click on a node, you can check the displacement values for that node from the information table. And when selecting an element, you can check the internal displacement values in the position that you clicked. For the internal force diagrams, you can select specific elements for showing the diagram. Also, you can change the scale, and by clicking on elements, you can check the internal force values on that specific position inside the element. All of these results can also be exported in a text format here in the options menu. And now I will change the analysis type for dynamic to show the available results for this type of analysis. You can see that the dynamic load case has different attributes like concentrated masses and dynamic loads. I need to run the analysis again, and of course it takes a bit longer. And now I can check the results for dynamic analysis. It includes the natural vibration modes of the structure, where you can select one of them and play the animation. The animation of the motion of the structure is also available. You can control the scale of these animations with this slider, and also the speed here from the options menu. And for the internal forces, the program provides the envelopes with the maximum and minimum values for that internal force throughout the analysis, as you can see here for the shear force. And graphs for the transient response can be plotted in an auxiliary dialog. Here you can check the displacement, velocity, and acceleration of a specific degree of freedom along the time and also the frequency. You can also check the contributions from the free and forced vibration to the results. And all these graphs and data can be exported. And that's it for this tutorial, which was more of an overview of the program. So thanks for watching.